The copper vacuum in U.S. geopolitics of high-voltage infrastructure. Imagine a critical power transmission megaproject in an emerging market. The foundations are poured, the towers are erected, and the local government is weeks away from connecting millions of people to reliable electricity. But the project suddenly halts. They are missing one vital component: the step-up transformers for the main substation. The delay isn't caused by a lack of local funding or engineering failures. The delay happens because thousands of miles away, an American tech giant decided to build a new 1,000-megawatt artificial intelligence data center. Armed with effectively unlimited capital, the American firm quietly outbid the emerging market for the exact same heavy electrical hardware. This is the silent siphon. The United States is currently undergoing the most aggressive power grid expansion in a century, driven by the collision of aging infrastructure and unprecedented AI energy demands. But the US does not manufacture enough of its own hardware to survive this transition. Today, we are going to look at the global macroeconomic fallout of America's infrastructure deficit. We will break down the extreme bottlenecks in grain-oriented electrical steel, why the global copper supply is facing an institutional liquidity crisis, and how the United States grid is effectively vacuuming up the world's heavy electrical components, leaving developing nations in the dark. To understand the global hardware shortage, we have to look past the wires and towers and focus on a highly specialized, brutally scarce material: grain-oriented electrical steel, or GOES. If you want to build a large power transformer, the beating heart of any high-voltage substation, you cannot use standard steel for the magnetic core. You must use GOES. This is an ultra-refined iron-silicon alloy that is meticulously rolled so that its magnetic properties are optimized in a single, specific direction. This minimizes energy loss when stepping lethal voltages up or down. The problem? Manufacturing GOES is incredibly difficult. It requires multi-billion-dollar mills and highly guarded metallurgical formulas. There is only one domestic producer of this steel left in the entire United States. The rest of the supply must be imported. As American utility companies and tech giants scramble to build massive new substations, the demand for grain-oriented electrical steel has broken the supply chain. Lead times for transformers have skyrocketed past 144 weeks. But this is not a localized issue. The global market for this steel is a fixed pie. When American buyers, armed with deep private equity pockets and federal infrastructure subsidies, aggressively lock in contracts for the next 3 years of production, they drain the supply pool for the rest of the world. Global infrastructure projects are essentially placed on an indefinite waitlist because the core materials are being swallowed by the US market. While overhead high-voltage lines use aluminum conductor steel reinforced cables, the sheer volume of copper required for the underground interconnects, the transformer windings, and the internal architecture of the data centers themselves is staggering. The energy transition is fundamentally a transition into copper. For institutional traders and macroeconomic analysts, this physical infrastructure bottleneck translates directly into violent market shifts. We are looking at a structural supply deficit. Mining operations take 10 to 15 years to scale, but the US grid needs the copper today. When smart money looks at the sheer physical tonnages required by US utility companies just to maintain baseline operations, they don't see a temporary trend, they see a massive fair value gap in the commodities market. The physical demand is acting as a liquidity sweep on global exchanges. American demand is outstripping the Earth's ability to pull the metal out of the ground. And because copper is a globally traded commodity, this artificial price inflation hits everyone. An engineering firm trying to electrify a rural grid in Africa or Southeast Asia now has to pay severe premiums just to acquire the raw wiring, throwing their financial models into complete disarray. This dynamic is fundamentally rewriting the geopolitics of the 21st century. In the past, nations projected power through naval fleets and oil reserves. Today, national security is directly tied to high-voltage infrastructure and the ability to secure step-up transformers. By hoarding global supplies of heavy electrical equipment, the United States is inadvertently stalling the development of emerging economies. When you monopolize the raw materials of electrification, you monopolize the future of industrial manufacturing healthcare stability, and digital integration. The Global South is being forced to compete in a bidding war against Silicon Valley trillion-dollar market caps. It is an unwinnable financial war. Until global manufacturing capacity for heavy electrical hardware drastically scales up, the American grid expansion will continue to act as a black hole, absorbing the resources necessary for global modernization. Over the course of this series, we have looked under the hood of the largest machine ever built by human beings. We've seen how AI data centers triggered a 76% surge in wholesale power prices. We explored the multi-million-dollar fortresses of high-voltage substations and the staggering 8-year traffic jams of the interconnection queue. The power grid is no longer a boring utility. It is the absolute bleeding edge of macroeconomics, civil engineering, and global geopolitics. Trillions of dollars are moving, supply chains are fracturing, and the physical limits of our infrastructure are dictating the speed of human progress. The energy transition is not just a policy debate. It is a war of raw materials and heavy iron. Thank you for joining me on this deep dive. If you are an investor, an engineer, or an executive navigating these physical bottlenecks, make sure to subscribe to USA Grid Mechanics. We will continue to break down the exact forces shaping the future of global power.